Do you know which unsolved mathematics problem puzzled several brilliant minds for centuries? This is simple, yet interesting, like a treasure chest lying on your doorstep, ready to be opened. We are talking about the most tantalizing puzzle, one of the oldest unsolved problems of mathematics, the Goldbach conjecture. It was published in English mathematician Edward Waring's Meditations Algebraicae and was first proposed by a Russian mathematician, Christian Goldbach, in his letter to the Swiss mathematician Leonhard Euler in 1742. Goldbach was connected with some important research specifically related to number theory. The proof of this question has been tricky for almost 3 centuries. But is it really something difficult? Probably not. At the first sight of it, it might seem so easy to anyone. It is a riddle that is so straightforward that even a young child could easily grasp it. But even though it is so simple, it remains unsolved to date. Several brilliant minds tried on this, but eventually gave up. So what's the big deal? Well, the famous Goldbach conjecture originally stated that every number greater than 2 is an aggregate of 3 prime numbers. This was based on the convention when 1 was considered to be a prime number, but that convention is no longer followed. The modern definition of the Goldbach conjecture states that every number greater than 2 is an aggregate of 2 prime numbers. This recent definition is equivalent to Goldbach's original statement, but it is written in the light of the modern definition of prime numbers. Well, let me just explain to you the conjecture with some examples. 6 equals 3 plus 3, 8 equals 3 plus 5, 10 equals 3 plus 7 equals 5 plus 5, 12 equals 5 plus 7, 14 equals 3 plus 11 equals 7 plus 7. So have you seen how simple it looks? Doesn't it? But that's the twist. It is an enigma wrapped in the plainest of mathematical clothing. Goldbach's conjecture has such a fantasied status in the world of mathematics. So this is actually the simplicity of the question, coupled with an absolute mystery that makes it so captivating. It is the puzzle that lures mathematics lovers with its apparent ease, yet it has defied even the brightest mathematician in the world. Something that appears to be so basic has resisted solution for centuries, only adds to its allure. Every failed attempt has brought us one step closer, revealing how much more there is to unveil in the world of numbers. Let me just break it down for you. Picture this with me. You are at a mathematics party and there is a huge bowl filled with even numbers. Now you are limited to picking one from the bowl, but you cannot choose 2 because it is the oddball. Quite literally. Next, your task is to split the number that you have picked from the bowl into 2 prime numbers, like splitting a bar of chocolate into 2 perfect pieces. Sounds easy, right? Up till now, regardless of the years of intense work, the answer to this mystery is still cloaking somewhere in the gigantic sea of numbers, waiting to be explored. But here is where it gets more interesting. Even though the problem sounds simple, these prime numbers are like an inexplicable cat. It doesn't follow any proper expected pattern. This is the reason which makes the Goldbach conjecture so difficult to track down. So no one can crack the code so far, and while trying to puzzle out, it has been tested for even numbers up to 4 trillion. Sounds unbelievable? Talk about pushing the limits. So you must be thinking, why should we care about this ancient puzzle? Well, the unsolved Goldbach conjecture isn't just a maths problem. It is a golden key that will help us to understand the mystery of prime numbers, the foundation of all mathematics. If some brilliant mind could be able to prove this conjecture, it could unleash new intuitions into the way numbers interact, and it may open doors to breakthroughs in some other areas of maths. But there's something more related to this. Prime numbers are important to cryptography, which is necessary to keep our digital space safe. So, a solution to this age-old problem could even affect the way we safeguard our online data. The hunt for this solution has extended over the generations of mathematicians. Mathematicians have tried to find an answer to the conjecture using several approaches, including statistical, probabilistic, and analytic number theory. The journey began with Leonhard Euler in the 18th century, who was a Swiss mathematician. He solely dedicated himself to the Goldbach conjecture, and while he couldn't provide an overall solution, he did manage to prove it for the smaller numbers. His work laid the foundation for future mathematicians to build upon. Next, in 1937, a Russian mathematician Ivan Vinogradov took a major advance by proving that the conjecture is basically true for all sufficiently large numbers. But the irony is that he couldn't specify what sufficiently large meant. His work is known as Vinogradov's theorem. Later in the 20th century, a Chinese mathematician Chen Jingrun proved that every sufficiently large even number is the sum of a prime, and a number with at most 2 prime factors. Then computers came and changed the entire game. They were used by mathematicians to test the conjecture for large numbers. The first among these mathematicians were a duo, Thomas Oliva E. Silva and Sylve Party, who used a supercomputer to check all even numbers up to 4 trillion in the 21st century. Harold Agot, who was a Peruvian mathematician, made remarkable advancements. He proved the conjecture for all odd numbers that were greater than 5 and all even numbers greater than a certain threshold. While this threshold is shockingly high, it was one more step closer to a complete solution. And let's not forget the number of unrecognized mathematicians mathematicians who strive their way hard on this long journey that hasn't ended yet. Every attempt of these bright minds brought us closer, but the final solution to this riddle is still out of reach, yet to be discovered. Now, the question is, where does it leave us today? There's a remarkable advancement in the field of technology and mathematics, but the Goldbach conjecture being unsolved still taunts us. The mathematicians keep returning to this interesting problem as it's like the best cliffhanger they've ever experienced. These bright minds haven't left any stone unturned to solve this ancient mystery, but they've failed. Each failure has been a stepping stone, and each attempt is a beacon of light revealing the path forward. But will anyone be able to solve this tantalizing riddle ever? The question remains. Who knows? But there's one thing for sure. This puzzle will spark the curiosity of anyone willing to dive into the magnificent sea of numbers. Goldbach conjecture is a challenge that appeals to both newcomers and experienced mathematicians, providing never-ending opportunities to learn, explore, and question. Surely this is not just about exploring the solution, but about the journey of uncovering itself, which will reveal the complexity and beauty hidden behind this number game. If this journey into the world of mysteries of mathematics has fascinated you in any way, then don't forget to like and share this video with some of the math lovers. Comment down below if you think you can solve this baffling puzzle. Who knows, the next mathematician that will crack this problem is you. Subscribe for more such interesting videos, and until then, keep exploring and keep wondering, because the world of mathematics is filled with questions that still need to be answered.